Welcome, my dear JEE 2026 Sigma aspirants. As you all know, we promise that within 1 year, you are going to ace it in the year 2026, be it your JEE mains and be it your JEE advance. And that's why we have the Sigma batch with obviously the Sigma teachers. And the name has been, aptly decided because literally, guys, this batch is a true Sigma. So welcome aboard. And we thought, why not give a demo? Why not teach a small subtopic of a chapter, so that you guys know what it is all about. You might have seen my old videos. If you have not, fine. Welcome to the live class. So, always a live experience is the best. Already in the Sigma batch, my entire previous year videos recorded repository is going to be freely available for all the students apart from the regular live classes which are there. So that is one cool thing which is going to be very, very fruitful for all the students. So welcome, my dear students. Hi, Aureshwar, Srinav, Isagi, welcome, Suri, Sanitha, Nareen, welcome. So let's begin. And before we start, let me quickly introduce myself, right? So my name is Shreyas. You can call me Captain Shreyas. Yep. And I have been leading this JEE ship for a very long time. I cleared my JEE back, like 20 years back almost. Yeah. And I almost secured full marks in my physics paper of JEE Advanced that time. And yep, I've been training kids for more than 13 years now. Before that, I was in a software engineering firm. And then, I'm very proud that every year I touch upon so many students. I am mentoring, guiding, helping many kids out there who are entering into IITs, AIMS, GMCs, NITs, BITS, you name it. And here I am, so that this year also all the students who probably wasted their year or probably are taking a drop or somehow realize that their true ambition is IIT, want to crack it within a year. So if you are with that goal, then stay tuned till the end, because this mentorship, this guidance on the Vedantu J English channel is going to be very, very fruitful. So quickly subscribe and smash that like button down there. Okay, cool. Right. So let's begin. All right. So which chapter are or which topic are we going to do today? We will do a part of relative motion. All right. So today we are going to do a part of basically relative relative motion. Relative motion. Okay. Now the name itself suggests certain aspects of it, like relative means it is with respect to something. So this word relative stands for with respect to. It's, uh, it's something which is not absolute. It is with respect to something. So when it is with respect to something, what is that thing and what are you exactly seeing? You are seeing the motion. Motion is basically movement, right? Motion is nothing but the movement. Now this movement can be anything. It could be your velocity, it could be your displacement, it could be your acceleration, all these kind of things. So what do I mean by respect? So let's understand that. And to understand that, we need to take help of something called as the frame of reference or the observer. So this is the most important thing in relative motion, the frame of reference, the frame of reference, which is basically the observer, which is basically the observer. In physics, without the observer, it is all meaningless, because depending on who is observing, the outcomes might change. That sounds strange, right? For a normal person, depending on who is noting down the experiment, the outcomes might change. They might see different things. They can draw different conclusions. Like, for example, say I am traveling in a bus. My luggage is with me. For me, the luggage is at rest. I am the passenger, I am moving. For me, my own luggage is at rest. But for my friend who is saying bye bye to me, for him, that luggage is moving. So, two different perspectives, I and my friend, and two different conclusions. I tell that the luggage is stationary. The friend says the luggage is moving. Who is right? Both are right in their own perspective, in their own way, in their own observation. Nobody is wrong. Okay, a lot of you think so. No, sir, actually, the luggage is moving. There is nothing called actually. That is what I want you to, you know, convince yourself rather, or, finally understand that there is nothing like actually. It is all what you see. All right, it is for you, that is correct. For you, that is the absolute truth. So observer, you can also call it POV, or the point of view. The point of view, right? So the point of view can be different. So just to give an example out here, like I gave you over just back. So this person over here might say that this luggage is at rest. So he might say the luggage is at rest. That's what he will say. Whereas some other dude over here who is standing on the ground, he will say that the luggage is moving. That the luggage is moving. They're right in their own perspective. So this guy is also right. This person is also right. This is just the point of view of seeing things. Now, whenever you have a point of view of seeing things, you need to tell me, say for example, I'm looking at the luggage. Where is the luggage? When am I seeing it? So that point of view always has two things. Where are you seeing it? And when are you seeing it? Where and when? For example, I see the luggage 2 meters in front of me at the same level and you don't have to go left or right. When am I seeing it? I'm seeing it at 5 o'clock. So you need to tell me where and when. This is very, very important. Why the when is important? Because I might say, yes, the luggage is there 2 meters in front of me. You don't have to go up or down. It's just there under the seat. It's not left or right, just directly in front. But you might sleep off and you might doze off, and then you wake up and you don't find your luggage. So now it is missing. That position has changed. The location has changed. Maybe the luggage was stolen by someone. So where it is and when it is, all that matters. So where is basically position. When is basically, come on, answer with me. When is basically the time. So where is nothing but the position of that particle, and when is basically the time. So if you have an observer like this person over here, so this person is generally considered to be as the origin of his own frame of reference, own point of view. He will be at the origin and he will draw his own x-axis, y-axis and z-axis, and he will carry with him a stopwatch. That is for the when part. So he will have his own stopwatch to measure basically the time. So he will measure time from here, and from these he will say the x coordinate, the y coordinate and the z coordinate. Are these lines in real? No, these are just imaginary. I can choose this as x, this as y, and that as z. Somebody will choose this as x, that as y, that as z. That's perfectly fine. When he's making those observations, he will start the time for himself. Oh, now I start seeing the bus. For him, the time might start at any moment. Time is zero. For him, the moment he decides to start observing, the moment he decides to make those observations. So some other person, like over here, He might be having a completely different perspective. He will have his own frame of reference. He will have his own frame of reference, his own stopwatch. Everything will be different. So he's a different observer. He's a different observer, right? He will have his own x-axis, his own y-axis, his own z-axis, and his own stopwatch. It's a completely new frame of reference. He might start observing after 5 seconds or 10 seconds or before 5 seconds or before 1 hour. So for him, time might be, showing a different value. Is that clear? Everybody understood till this point? Yes. Harshita, I will be taking the classes in the Sigma batch along with your PNJ sir. Yep. Together, both of us IITians in this particular batch. Yep. Okay. Great. Great. Captain Sapari, welcome. Welcome. Yep. Hi, Srinav. Yes, this is your relative motion chapter. Good evening, Aruneshwar. All right. Great. So now that you understand, okay, observer, the point of view matters. The point of view will always need where and when. Where means the position like X, Y, and Z, and when means the time. So how are we exactly going to calculate these relative motions? How exactly are we going to calculate these relative motions? Let's have a look at it. Okay, ready for this? How do we calculate these relative motions? Let's see and understand. Now, say for example, okay, we are in this particular bus or car, whatever you want to call it, and in this particular bus, you are moving, or car, you are moving at a speed of 50 meters per second. In front of you is another vehicle, another car, another bus, whatever you want to call it. And maybe that bus or that car or that vehicle is moving opposite of you. Yes, it is moving in the exact opposite direction like this with a speed of, example, 20 meters per second. Okay, 20 meters per second. In some another scenario, let us say, for example, we have that same bus or same vehicle going this way with a speed of, let's say, 30 meters per second. And this particular vehicle in which you are observing everything, maybe this is now moving at, I don't know, maybe 60 meters per second. Chumma, I'm taking something 60 meters per second like. So I've just taken two scenarios. We can also take even more directions. Okay, say for example, I just change few things over here. Say for example, I can just take this guy moving like this with a speed of 20 meters per second. Maybe now this guy is going like this with a speed of 30 meters per second. And maybe this person is moving like this with a speed of 70 meters per second. Okay, I can choose anything, or I can make this 10 meters per second. Doesn't matter, guys. Chumba, I'm taking all different speeds, all different directions, all weird things I'm taking. All right. So in each case, let us say, for example, my observer is in this blue bus. Observer is in this blue bus. Observer is in this blue bus or blue vehicle and looking at that pink vehicle. Looking at the pink vehicle. What will be the relative speed? That is the question. What will be the relative speed? That is the question. Okay, so let's try and understand that. In each case, what will be the relative speed of the pink vehicle with respect to the blue vehicle? Now, some of you might get it directly. I will teach you a trick now. See, if you look at this scenario, in 1 second, just imagine this. In 1 second, this blue bus travels 50 meters. This pink bus will travel 20 meters. So 50 meters, 20 meters. Together, how much have they moved closer towards each other? Can you guys quickly tell me in the chat box? Yep. Can you quickly tell me in the chat box how close are they moving at in 1 second? In 1 second, how close are they moving? Yes, they have moved 50 and 20. So together they have moved 70 meters closer. If they were some 100 meters or 200 meters away, now 50 meters I move, 20 meters that person moves. So we have reduced our distance by 70 meters in just 1 second. Next 1 second, more 70 meters. Next 1 second, more 70 meters. So every second, my distance is reducing relatively by 70 meters. So can I say that the relative speed is basically 50 plus 20, which is nothing but 70 meters per second? Everybody with me? Very good, Tejas. Excellent. Yep, awesome. What about the second scenario? This person going this way, this person going that way, this person observes the pink bus. So, in 1 second, I have moved 60 meters here. This pink vehicle has moved 30 meters. This blue vehicle moves 60. The pink vehicle moves 30. So my separation has not only increased by 60, but also by another 30. So 60 plus 30 is 90. So next 1 second, further 90 meters. Next 1 second, more 90 meters. I will keep on separating myself from the other. So can I say that the relative speed in this scenario is also 60 plus 30, which is nothing but 90 meters per second? Everybody with me? Everybody understand this? Perfect. Okay. Now let's go to this scenario. I'm in the blue bus looking at the pink bus. I'm again trying to figure out what is the relative speed of the pink bus as seen by me, the observer in the blue bus. Okay. In 1 second, I have moved 50 meters. The bus ahead of me has moved in the same direction by 20 meters. So think about it. I moved 50. The bus in front of me only moved 20. So think I have actually got closer to the bus. I have actually come closer to the bus by 30 meters in that 1 second. I have actually come closer to the bus by 30 meters in 1 second. I move 50 meters. The bus in front of me moves only 20 meters. So 20 and 50, how much is remaining? I have come closer by 30 meters in that particular second. Are you able to visualize this? Everyone with me? Yep. So the relative speed will be 50 minus 20, which is nothing but 30 meters per second. Okay, crazy. What about this scenario? What is this relative velocity going to be? I am in the blue bus looking at the pink bus behind of me. I move 10 meters in 1 second. The bus behind of me is moving faster by a speed of 30 meters per second. So in 1 second, I travel 10 meters, but the bus behind of me, it travels 30 meters. It has traveled 30 meters. So out of that 30 meters, 10 meters I also have traveled. So what is the relative velocity? What is the relative velocity? Think about it. The bus behind me has traveled, or the vehicle behind me has traveled 30 meters, but no issues. I also traveled 10 meters. So actually, the relative distance by which the vehicle behind me has come closer is only 20 meters per second. So this will be nothing but 30 minus 10, which is 20 meters per second. Yep, very good. Excellent. So now you might be thinking, sir, every time I have to visualize so much. I will teach you a trick. I will teach you a trick by which you don't have to. Actually, you should, for understanding, you should visualize initially. But in the exam, you won't have so much time. Oh, I have moved 10. Oh, you have moved 20. Like this. You will get confused. I'll teach you a trick. Simple, guys. Are these two vehicles going in the opposite direction? Are these two vehicles in both the scenarios on this slide moving in the opposite direction? Yes or no? Come on, quickly think and tell me, are they moving in the opposite direction? Opposite direction. If their directions are opposite, what is the symbol of the word opposite? Antonym, cross, right? Opposite means like this. Opposite means like this. Opposite means like this. Okay, do one thing, just rotate that symbol. Rotate that symbol of opposite. What will that symbol become? It will just become plus, right? It will just become plus. Exactly. That means you just need to add the speeds. You just need to add the speeds to find out the relative motion, which is exactly what we have done. Plus 50 plus 20, 60 plus 30. Directly you can add. Very easy trick. So if they are going in the opposite directions, opposite means cross, turn it, it becomes plus, just add the speeds. Simple. What about in this scenario? In this scenario, as you can see, they are moving in the same directions. They are moving in basically the same directions. They are moving in the same directions. If they are going in the same directions, same, similar, what symbol do you use? Equal to, right? Same means equal to, yes or no? Just like for opposite you had cross, for same you have equal to. Now what you do is merge these two lines. Yes, merge these two lines. Merge these two lines. What will that equal to become? That equal to will become a dash. That equal to will become a dash. What sign is this? This is basically subtraction symbol. This is basically subtraction symbol. When you merge these two lines together, it becomes a minus symbol. That's exactly what we have done, 50 minus 20. But always subtract big number minus small number so that you get a positive answer. Okay, so big number minus small number will give you a positive difference. Yes, so that is all that you have to do. Now, isn't it simple? No matter what it is, you can easily get the answers very easily. Shall we do now take some examples? Shall we take some examples? Okay, so let's try it out. Say for example, there is one apple. There is one apple which is falling down with a speed of 25 meters per second. There is another fruit, some orange or something, which is falling down with 15 meters per second. Can you quickly tell me what is the relative velocity? Come on, my dear students. What is the relative velocity between them? What is the relative speed between them? Quickly think and tell me. Both are moving in the same direction. Same means equal to. Put it together. Minus, that's it. So big number minus small number. So 25 minus 15, which is exactly 10 meters per second is the relative speed. Isn't it simple? Very easy. Okay. This not only works for velocity, but also for acceleration, by the way. Yeah. Say for example, there is a police vehicle. Police vehicle is accelerating at 3 meters per second square, and the thief vehicle is accelerating at maybe a 10 meters per second square. Can you tell me what is the relative acceleration now? Can you quickly tell me what is the relative acceleration now? It works for velocity, acceleration, displacement, everything, guys. Okay. Yes, they are moving in the same direction. Put it together. That's it, guys. They will be subtracted. So 10 minus 3, which means the relative acceleration is 7 meters per second square. Simple. Yep. The next chapter I will be teaching Jesus. Yes, the next one. Okay, coming up in the Sigma batch. Next, let's say for example, there is one person, Pandu, who is running towards another girl whom he loves a lot. They are meeting after a very long time. This girl also is loving him a lot. So they move towards each other. Pandu moves 7 meters, Champa moves 3 meters. What is the relative displacement? S is the symbol for displacement. So that's why I'm using S, relative, because it is, we are respect to each other. What is the relative displacement? Just check that out. This guy and this girl both are moving in the opposite direction. Opposite means cross. Turn it. So plus. So 7 plus 3, which means 10 meters is the relative displacement. Isn't it simple now? Everyone with me? Is it simple? Now you can never make a mistake on this. You can never ever make a mistake in this kind of questions. Yeah. So whenever you want to calculate relative velocity, relative acceleration, relative displacement, then either it will be plus or minus depending on whether they are opposite, their motion is opposite or moving in the same direction. As simple as that. Okay. Now, usually in your books, what happens is when they ask or give you the formula for relative motion, you will always see a subtraction. And you might be confused why they always use subtraction, but actually sometimes it is added, sometimes it is subtracted. So I'll tell you why it is. So when I say relative motion of say B with respect to A, it means A is nothing but the observer. A is nothing but the observer. Symbolically writing, you write it like this: velocity of B with respect to A. So that symbol A comes later on because he is the observer. So whoever is the observer comes later on. B is being observed. So what is B? B is being observed. It is being observed. It is not the observer. It is the object in this case. This you will see vector wise is always very, very important. Whatever is the velocity of B, from the velocity of B, from the velocity of B, just remove 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 is motion, is motion. So whatever is left over, is that relative motion. So from B's motion, remove whatever A has, whatever is left over, whatever is left over is basically the relative motion, is basically the relative motion. So that is why you will see the formula goes like this. It is velocity of B minus velocity of A. So VBA is VB vector minus VA vector. This symbol stands for the vector notation. It is a vector equation. It is a very sign sensitive equation. So this always holds true no matter whether they are going in the same direction or in the opposite direction. So you might be wondering, oh, there is always minus, sir, in this vector equation. So just now you said sometimes it is plus, sometimes it is minus. Wait a minute, I'm confused. No worries. Hear me out. Okay, let's talk over here. Let's talk over here. Here, we call this, let's say, A everywhere. Let's say we call it as A. Let's say we call it as A. And this person being observed is B. Whatever that pink vehicle is basically B. So let's say, for example, what we want now is nothing but velocity. What we want now is velocity of B with respect to A, correct? Vector wise, which is nothing but VB minus VA, as per this formula, which I just told you, which is VB minus VA. Now the catch is that when you put the value of VB or put the value of VA, it has to be as per the sign convention. Meaning whatever is on the, let's say, positive side, right side will be positive example, and whatever is on this side, let's say, is negative. Whatever is up is positive, whatever is down is negative. So you have to be careful with the signs. So if you are careful with the signs, you will quickly understand what will go on. Velocity of B, can you tell me? Will it be plus 20? No, it is negatively pointed. So therefore, technically it will be minus 20. Technically it will be negative 20. That is the value of VB minus VA. What is VA? It is going in the positive direction. So therefore, it will be plus 50. Plus 50. So what is this? Minus 20 minus 50. What is it going to be? Minus 70 meters per second. So if you look at the magnitude of velocity, the modulus, that modulus is still going to be 70 meters per second. The modulus is exactly what we got. So if you substitute the proper signs, you will still get the same answer. with the formula. Let's try it out again with this example. Let's try it out again with this particular example. Velocity of B with respect to A is VB minus VA. What is VB? VB is positively moving, so I shall put plus 30. VA is negatively moving, so I shall put minus 60. Negative of a negative number becomes positive, so it will become 30 plus 60, which is 90 meters per second. But if you want the modulus of a positive number, it is also the same thing. So it will be 90 meters per second magnitude wise. Exactly what we got. Exactly the same thing. So does it matter, guys, whether I use the trick or whether I use the formula? No, the answer will come out to be the same. We can do it over here also. Say for example, velocity of B with respect to A will be VB minus VA. What is VB? It is moving in the positive direction, right side, so plus 20. VA is basically also plus 50. So 20 minus 50 is negative 30 meters per second. But that's the vector, of course. I am interested only in the magnitude. Then it will be speed, not the velocity. Then it will be just 30 meters per second. It's the exactly the same answer. Try it out over here. Velocity of B with respect to A will be VB minus VA. So what is VB? VB is obviously negative 30 because it is going on the left side. VA is also negative 10. So this will become minus 30 plus 10, which is minus 20 meters per second. Again, if you just find the magnitude, which is the mod value, it will be just 20 meters per second, which is exactly what we got. So the point is, whether you use my trick or whether you use this formula, which I have shown over here, you will always get the same answer. You will always get the same answer. Everyone, thank you, Mati. I'm so glad that you are able to score 97 percentile in mains. I'm so glad you came back to tell this and you are a passing out student. Yes, I'm so glad, Mati. I hope that your JOSA counseling goes really, really well and you get a really good NIT or a satisfactory branch. And I'm pretty sure you are going to do really well in life and all the best for the first year of your college. I'm so proud that you will be entering college. You will not have to worry about anything. So forget about all the mistakes or whatever you couldn't do, whatever you didn't get, etc. 97 good percentile. Go ahead, my dear. Proud of you. Proud of you. Thank you so much for coming here. Okay. So, did you understand this concept? Okay. Did you understand this concept? Let's do this by a proper formula. The next question, let's do it by proper formula. Let us tell, say for example, maybe this police, or maybe there is a police vehicle which is going like this, and the police vehicle has a speed of 5 meters per second, and the thief happens to go like this with a speed of 20 meters per second. Can you quickly figure out what is the velocity of the police with respect to the thief? Come on, use the formula. VPT. VPT. Go in order. VBA is VB. B comes first minus VA. So from VB, you suck away A's velocity. Whatever is left over is the relative velocity. So VPT will be VP minus VT. So what is velocity of the police? Check that out. It is negative 5, isn't it? It is negative 5. Okay. What is the velocity of the thief? It is positive 20, isn't it? So what will this be? It is minus 5 minus 20, which is minus 25 meters per second. But if you go with the magnitude part, it will be plus 25 meters per second. It will be plus 25 meters per second. Perfect. What about this, guys? What about this? If I do VTP, it is exactly opposite of this. It's exactly opposite of this. It will be VT minus VP. What is VT? What is VT? Yes, what is VT? Check that out. It is nothing but positive 20 because you are going on the right side minus velocity of the police, how much is it? It's -5. It's going on the left side. So -5 over here. So 20 minus minus will become plus. So again, it will become 25 meters per second. Even if you check the magnitude of it, the mod value, it will be still 25 meters per second. Perfect. Exactly what you would expect. So in conclusion, the relative speed, whether you check with respect to this or that, is 25 meters per second. Is 25 meters per second. There is one interesting thing though, which I would like to conclude. If you look at the velocity vector, the sign, this is -25. This came out as +25. This came out -25, that came out as +25. Sir, why take right as positive? It is just a convention. You can choose your own convention. Like I can say, for me, 100 million is equal to one currency of my own thing. It's just a thing in your head. So I can take upwards as positive. I can take downward as positive. It's your own convention. In that convention, what is it? That's all. Is that okay? Hey Maya, it's just a matter of choice. Anybody can take right side or left side or upside or downside or front side or back side as positive. As per the usual conventions, right side are positive, left sides are negative. Usual. There is no harm in taking something else. It's perfectly fine. Okay. There is one thing though. VPT is negative, VTP is positive. If this was negative, this will be positive. And it makes sense that had I just flipped this, instead of VBA, had I made this as V, but this as A and this as B, guess what? This would be VA minus VB. Obviously, this would be nothing but VA minus VB, isn't it? This would have been just VA minus VB. Oh, so that means if I have VAB, if I have VAB, can I say it is exactly negative? That's very important. It is negative of V what? BA. VBA. Exactly opposite. So this is positive, this is negative, this is negative, this is positive, which is exactly what we got over here. VTP was +25, VPT was -25. If you change the order, obviously you will get a negative answer. This is another important thing which you will see in this particular chapter. It makes sense. If I see Champa coming towards me, maybe towards the west side, maybe this is west, that is east, that is north, that is south. So if I see Champa coming towards me towards the west, Champa, as she is moving, she will see me going towards the east with the same speed. So it is exactly reversed, but of the same magnitude. It is exactly reversed, but of the same magnitude. Absolutely clear, my dear students? Perfect. So this is basically your relative motion. So all our classes are on the big screen. They are not on the small screen. That's very important. Just to show you, say for example, once you have enrolled into the Sigma batch, this is how your page will look like. Okay, you can go to the schedule, you can see the live upcoming classes, when is it going to be, etc. If you have missed a class, it will come over here. Okay, and the notes, the replays, everything will be available over here, right? So this is some other batch which I have shown you, but this is how our screen looks like. Okay, so you miss it, no issues, you can check out the notes. You click on this, you will see the notes are available, or even if you have not missed it, it's perfectly fine. All the notes are as it is over here. You can also watch the replay at your own convenience in case you are missing out due to some reason. Okay, so you can watch the replay as well. Cool. So this is how our JEE Sigma batch is. So if you are clear about your IIT goals, there should be no doubt in your mind that Sigma batch is literally the Sigma batch, because first of all, you are getting IIT and teachers, you are getting experienced teachers, you are getting a committed institute to complete the syllabus, just like we did last year, before that, and because there are a lot of batches which do not complete the syllabus. Now, number two, guys, it's not just completing the syllabus, there needs to be revision done also. So complete revision. After the portion is completed by October or November, we complete entire 11th and 12th. It's not 12th alone, entire 11th and 12th. That's why we have two teachers, sometimes three teachers in chemistry, so that the syllabus can be completed in detail with, the proper schedule and within that time frame. And after that, revision will start. You have the final mock test series just before your mains attempt. And after that, if you still don't clear, no issues, we'll help you with the April attempt. If you clear in January only, we will start with the JEE advanced preparation. So don't worry, don't get scared, sir. I clear in January only. So we'll have to again sit for April. No issues. You start with your advanced preparation. We will have separate things. Sir, I did not clear in Jan. Sir, will you help me for April? Of course, man. Of course, we are going to help you for April attempt. And for sure, you will clear it by April, worst case. And after that, will you help us for JEE Advanced? Yes. Okay. So it's a proper full-fledged batch. It's not for just droppers. It's not just for 12. It's for any student who wants to complete the JEE syllabus in 1 year. Okay. So the link is there in the description box. You can see it over here. Sigma batch for 2026. It's in pure English, entire physics, chemistry, mathematics. 29th May, that's tomorrow, it's starting. I hope you watch it on time. Live class, in-class doubt solving, post-class doubt solving. In the replay, you can ask the doubts. So don't worry about it. It will feel like a live class. Complete discussion of practice questions, previous year papers during the revision, all India test series, study material in the digital form, DPP generator, regular class tests, all India level tests, unlimited video concept lectures, my lectures, other teachers' lectures, apart from the live classes, and Telegram community, report card with a separate app for the parents. Everything is there. And these batches are at a very affordable price for 3,999 for our V Prime batch. This price was different. If you remember, this was 5,000. Yes, couple of days back. We have just changed it only because the batch is starting now. After that, the price will change. So please take the full benefit. See, this batch is also there, which is the same thing, but extra thing that you get is the revision flashcards, which will be couriered to you. Over here, you will get the Tattva soft copy, which is our full-on coaching modules, which will be couriered to you. If you are not happy with the soft copy because of whatever reasons, you want hard copy, no issues, go with this. If you want the revision cards, then go with this. This is the ultimate combo which you can get. These prices will also change just after the batch has started. So 29th May, the batch starts complete in English. All right. So I hope you enjoyed today's class. You learned it in a much better way. You saw the demo. So don't hesitate. Talk to your parents and make sure you're on the right track. You don't have to buy any other batch. You don't need any other coaching after this particular batch. This is a standalone batch which has everything that you need for cracking your JEE in 1 year. And believe me, you need to finish the syllabus by October, November, else you will be delaying your revision, and the revision is the most crucial thing. So let's revise with those lectures after November and give those mock tests, improve your scores, and 99% I feel you will be cracking it in January itself, so that you get more time for your boards or for your JEE Advanced or any other competitive exams. Cool? All right. So thank you so much, guys. God bless you all. Do not forget to smash that like button. If you have any concerns, videos, after the video is over, just put up a comment below. Okay. Bye-bye. Take care.